Hello guys, can you hear me?
Yes.
All right.
Yes.
Okay, is everyone here? No, I don't think so. Okay, so where are the rest? Did they attend the sessions, the previous sessions?
Yes.
Do you know where's Julie?
Maybe she's coming.
Okay. And Adham is here, okay. Abdul Halim.
The Jude is not coming.
Judy what?
She's not coming.
She's not coming?
Yes.
Why?
She's traveling.
Oh, okay. All right. All right, guys. So we have to do the correction of the exam again, unfortunately, because it has to be recorded on Zoom. So we're going to do it together. Yes, Ali. We're going to do it together quickly since we have done it before. So we're going to go through it. It's just going to be us doing this. Starting next session, we will be discussing, or will be continuing the fourth lesson. And we're going to have some fun doing this. And I prepared a video. It was actually a video that I prepared last year about the different types of forces and how do we see it in our everyday life. Hi, Lara. All right. So let's check together the exam. All right. So I wish that all of you were there in order to listen for this together. But it's all right. Okay. So yeah, here we go. All right. I'm just going to go through them really quick. Okay. So in question 1, by the way, your marks will be ready today. I will be finishing them through the day, and by the end, maybe at 7 o'clock, you will find your marks on Moodle. All right. So question 1 says, Abida makes a circuit with a bulb, cell, and a wire. So I noticed that a lot of you guys forgot to actually, or did not notice this part, okay? You are supposed to be drawing, as it says in this question, complete the diagram of Abida's circuit below by drawing the symbol of a cell and connecting the cell in the circuit, okay? So you just have to draw a cell, guys, because a lot of you drew another bulb. Some of you drew a motor. So and some of you even just you know, like matched the two sides together. Okay, so this is wrong. You have to draw a cell. All right. I think someone is in the waiting room. No. Okay, so you just have to draw a cell this way, a long line, a short line, and then you have to connect it to the rest of the cell, to the rest of the circuit. Okay, now question B says, Name the piece of equipment that Abida could add to her circuit so she can turn the bulb on or off. Okay, so again, a lot of you wrote she has to add a cell. Of course, this is wrong. We want to something that could make us control the circuit and turn it on or off. So of
Why?
course, the answer is what?
Switch.
A switch. No, dear, a switch.
Mira said
You're
wire.
Nancy, right?
No, Mira said wire.
Mira said wire?
Yes.
Why, Mira?
And Ahmed Ahmed said switch.
Huh? Do you think it's the wire is the one that controls the circuit?
No, of course.
The switch is the part that could make us turn the bulb on and off. All right? Okay. Question 2 says, Ben makes a series circuit using two identical cells, a bulb and a switch to turn the bulb on and off. Draw a circuit using symbols to show how Ben connected the circuit parts. Guys, this is not the wire. This is not a wire. This is a frame so that you know where you should draw the circuit. You have to draw the circuit inside this box. Okay, so this is not the wire. So unfortunately, whoever did this, like draw the two bulbs or the one bulb and then you continued like acting like this is the wire, and then you put the cells here and another cell here. Okay, and then a switch here. Okay, this is wrong. Okay, you should not use this frame as the wire, or yes, the wire for the circuit. Okay, you should draw inside this box. This box is made for you to draw inside it. Okay, so you're going to draw this way. Inside, you have to draw one bulb, and you have the parts right here, guys. You have only one bulb and two cells and a switch. So for the people who added an extra bulb, this is wrong again. Okay, you have to draw what you have in front of you. So you're drawing a bulb. Of course, I have to be drawing using a ruler, but I don't have a ruler here. And then you have the cells. Okay, and then you have the switch. Here you go. If you made the switch open or closed, both are correct. Okay? If it's an open switch or a closed switch, both are correct. Okay. Another mistake that I saw. Please, guys, put the cells next to each other. Why? Because you guys get confused when you put the cells, and in between those two cells, you add the load or the switch. How? I will show you right now. So I have the first cell right here, and then I will put the bulb. Okay, and I will put the switch right there. Okay, here you go. And then I will add another cell right here. Who's doing this noise?
I don't know.
Okay, now I want one of you to tell me what is wrong with this circuit. Why it's not going to work? Yes, Mira. Yes, Mira.
It will be dim because there's a bulb.
No, it's not going to work at all. Why, guys? Isn't it going to work at all? Do you know Ahmed? Ahmed Ahmed. Yeah, why, dear?
I think because the cell is in a place and the other one is in another
No,
place.
no, it's okay to have two cells in two different places. The problem is when you draw it this way, look at this. What side is this? Is it the negative side or the positive side?
Oh, yes.
This negative.
The negative side. And then when you go through with the wire, the negative side is actually facing the other negative side. So the two similar sides are facing each other. And this is why I always draw the two cells next to each other so I don't get confused like this. This is wrong. This is wrong because you have to pay attention to those small details. All right, guys? It saddened me because I know, guys, you can draw circuits very well. And this little thing made you get confused. All right? So here are the problems that I saw while I was correcting your exam. All right, next is question B. There is a dot in my waiting room. I don't know who is this. So please, would you please find out, because I cannot let him or her in. If you have a group or something, ask who is this, because I cannot let him or her in without a name.
Miss, I think it's Amr.
Okay, would you please make sure? And if it is Amr, tell him to write his name. Okay?
Okay.
All right, guys. So let's continue. Which part of the circuit supplies the energy? Of course, the cell is the one that supplies the energy. Ben adds another identical bulb to the circuit in series. How does the brightness of the first bulb changes? Okay, so he added one more load. He added one more load. So how will this affect the brightness? It will make the brightness, or it will make the bulb light dimmer. Okay, if he added one more bulb, he will make the brightness of the first bulb dimmer. Is it clear?
Yes.
It's very important, guys, that you read the question, because a lot of you don't read the question. And this gets you in mistakes. Like, for example, the next one. Let's look at the next one. How will the brightness of the bulbs change when the cells shown below are placed into Ben's circuit? Okay, now in Ben's circuit, we had only two cells, all right? So in this case, this one, we added one more cell. So this means that we added more power, or more power source, okay? So this means that it's going to be brighter because I added more cells. So how will this change the brightness? It will be brighter. But in this case, some of you wrote it's going to be dimmer. This is wrong. It's not going to be anything at all. It's not going to work. Why? Because the two similar sides are facing each other. The cells are put in a wrong way. So this means that the circuit will not work at all. Do you understand, guys?
Yes.
Yes.
Okay. Next is question 3. Andy builds the circuit below. The bulbs do light up. Okay. Andy wants to change his circuit so that the two bulbs. Oh, hi, Julie. Hi, dear. Andy wants to change his circuit so that the two bulbs are brighter. He can use any other equipment. Suggest 2 ways Andy can make his two bulbs brighter. All right, guys, just let me tell you something. Why am I telling you to read the questions very well? Do you see this? They said Andy can make his two bulbs brighter. All right, so removing one bulb is not an option, but I let it pass this time only. All right, I let it pass this time only. All right, so you need to think about other ways to make the two bulbs brighter. All right, the first thing is that you can use a thicker wire. The second thing is that you can use a shorter wire. The third thing, if you want to add a third thing or you want to replace any of the things that I said, is to add more cells. Okay, so thicker wire, shorter wire, more cells, all of those three answers are correct. Question number 4, it says, Lara took a shower and dried her hair with a hair dryer in the bathroom. What do you advise her to do? Tell her 2 tips for electrical safety. You can write any of the electrical safety tips, okay? It doesn't have to be related to water. Any of the electrical safety would work. I would accept any of the electrical safety tips. So if you wrote that you shouldn't use electrical appliances in the bathroom, it's correct. You don't have to use any electricity near water. This is also correct. Don't use electricity using wet hands, correct. If you wrote that you shouldn't touch a bare wire, correct. Don't overload plugs, correct. Okay, so there is a lot of things that you can write here, and most of you did it correct, so it's fine. Question number 5, Sue has a cell, which means a battery, some wire, and a bulb. She makes a simple circuit. So right here you have a simple circuit, and as you can see, she has those 2 ends. The crocodile clips are not connected to anything. This is why. This is because she's trying what we did in the lab. Do you remember when we went to the lab and we did this cell, this circuit, and we started connecting different materials into the circuit? So she's doing the same here. She has several things right here: a rubber, a plastic ruler, an iron nail, a copper rod, a steel spoon, and a piece of wood. So we want to know which one are the electrical conductors and which one are the electrical insulators. To my surprise, a lot of you were confused between the electrical conductors and insulators. We know that the electrical conductors is the materials that allow the electricity to pass through them. And this means that any metal is an electrical conductor, while the insulators are all the materials that do not allow the electricity to pass through them. Okay, so electrical conductors are like iron nails, copper rod, and steel spoon, while the electrical insulators are the wood, the plastic ruler, and the rubber. Okay. Question 6 says, the drawing below shows part of an electric cable and a plug. Now, as you can see, the cable has a copper wire inside it, and it has this insulating material covering the copper wire. Question 1 says, what material could be put around the wires to insulate them? In this question, I want you to give me an example of a material. I don't want you to tell me why am I covering them with an insulating material, okay? So a material like what? Like rubber or plastic. Some of you wrote wood. This is a little bit far from any practical things that we see in our daily life. But the one who wrote wood, they wrote rubber next to it. So I considered rubber is the correct answer. Okay, it's whether rubber or plastic. The second question, why is this insulating material needed? And this is where you have to write for me that we use the insulating material to not get an electric shock or to prevent getting an electric shock. Okay, or electrocuted, to prevent being electrocuted. All right, is it clear so far, guys?
Yes.
All right, perfect.
Yes.
Next is question 7. Question 7 says, the diagram below show a light bulb. What's wrong? Okay, it shows a light bulb over a staircase of a model house. Under each diagram, tick one box to show if the circuit is open or closed circuit. Okay, So simply what you have to do, yes, okay, Ruqayya, you can tell me the first one is?
is closed.
The first one is closed, huh?
And the second one is open.
Yes, the third one,
I can't see it.
do you see
Yeah,
it now?
the third one is open and the
Yes.
fourth one is closed.
Very good. Thank you so much, Ruqayya. All right. So now let's move to question 8. Question 8, an electrical circuit has 2 cells correctly arranged and 2 bulbs. Answer the following questions. Which circuit is a series circuit, guys? Which circuit is a series circuit? I have only 3 people since the beginning of the session raising their hands. Where are the rest? Which circuit is a series circuit? Yes, Nancy?
Circuit 2.
Circuit 2 is a series circuit. And which one is the parallel circuit again, Nancy?
Circuit 1.
Circuit 1, thank you. Question C says, in circuit 2, the bulb S does not light up. What will happen to bulbs T and R? Ahmed Ahmed.
What?
You got surprised? Okay. In circuit 2, bulb S does not light up. What will happen to bulbs T and R?
A second, we can add one cell.
Just give me 1 second. Okay. This is circuit 2. Okay. This is circuit 2. All right. Bulb S stopped working. What will happen to T and R?
T and R.
Yeah.
This is series, so they will close.
Yes, exactly. Because it's a series circuit, so they will turn off too. Thank you, Ahmed. D, in circuit 1, the bulb Y does not light up. What will happen to bulb X? Do I have any other? Yes, Salim.
What?
Yeah, what will happen to bulb X if bulb Y stopped working? Here's circuit number 1. Bulb Y stopped working. What will happen to bulb X?
Nothing, because it's a parallel circuit.
Yes.
And each wire has its own pathway.
Exactly. So bulb Y, because this is a parallel circuit, bulb X will keep working because it's a parallel circuit. Yes, Julie, do you have a question? All right, Ali, I want you to answer E and F, please. Identify the following symbols and then complete the sentence.
First one cell, second
Yes.
second one bulb, third one switch off
Yeah.
or open. Fourth one is motor. An
Okay.
unbroken circuit is a complete circuit, and the open circuit is a broken circuit.
Thank you so much. Or an incomplete circuit, it's also correct. Thank you, Ali. All right. So now question number 9. Sophia is investigating electrical circuits to see how they behave. What happens to the brightness of the bulbs? Of course, it's obvious that it's a series circuit. So Sophia, if she added another cells, if she adds another cell, what will happen to the brightness? What will happen to the brightness of the bulbs? Adham, are you there? Adham?
Yes, Miss.
Yes, can you answer this, please?
Sophie is investigating electrical circuits to see how they behave, what happens in the plants of the bulbs. Sophia adds another cell, it will be brighter.
Thank you so much, Adham. The bulbs will be brighter. Okay. Question B. Lena, are you there? Lena?
Yes, I am there.
Okay, I want you to answer B, please. Sophia now replaces the wire with a longer wire. What will happen to the bulbs? You're muted. Unmute your mic.
The light will be dimmer.
Yes, the light will be dimmer. Very good. Next, Sophia now replaces the wire with a thicker wire. What will happen? Abdel Halim. Abdel Halim.
Yes.
Sophia now replaces the wire with a thicker wire. What will happen to the brightness of the bulbs?
It will look brighter.
Yes, it will glow brighter. Thank you so much, Abdel Halim. Now, if Sophia uses a shorter wire, what will happen, Mira?
Yes.
Yeah, she's using a shorter wire. What will happen to the brightness of the bulbs?
It will be brighter.
It will be brighter. Very good. All right. So now we're going to the next question. Draw a parallel circuit using all of the below items. So right here, I'm going to draw the parallel circuit. And it's preferable, guys, that you put, as I said, the cells in the same wire. Okay? The cells are in the same wire. And then you can connect the rest of the loads in a parallel way. Okay, so I'm going to add a bulb here. Here you go. This is one bulb. Here's another bulb. Of course, it's messy because I'm trying to draw it on screen. And the last one is the motor. Okay, here you go. This is a parallel circuit. If you added the cell in another wire, it's fine. No problem. Okay, so yeah, which means that you put one cell in one wire and another cell in another wire, it's also correct. No problem. Okay. Next is question 11. It says soils can be identified using the key shown. So we have here an identification key for soils, and we have several questions under this key. The first question says, which soil does not retain water and is full of small stones? It's of course the gravelly soil. Which soil retains water and it is sticky when wet? It's the clay soil, and you can know it this way. Does it retain water? It says yes, it retains water. So yes. Is it sticky when wet? Yes, we want to know which one is sticky when wet. So it's the clay soil. Next is, does silt soil retain water? And we know that silt soil is one of the two soils that do retain water, but one of them gets sticky when it's wet, and the other one doesn't get sticky when it's wet. The last question, which soil is not sticky when wet? So we're just repeating the question. It's the silty soil. Next is question 12, and this is the last question in this paper. We have those three words, and we want to answer the following question. Number one, the group of rocks that are formed due to rocks exposed to very high heat and pressure are called metamorphic rocks. Number two, the group of rocks that are formed due to cool down of lava are called igneous rocks. Number three, the group of rocks where scientists can find fossils in are called sedimentary. And the last question have two correct answers. An example of a rock that was formed due to lava cooling down slowly. If you wrote igneous, I will consider it correct. If you wrote granite, it's also correct. All right. So this is it for paper one. We have about 6 minutes left in this session. So we are going to start anyway with paper two until the session ends. Okay?
Miss,
Yeah.
can I go to the bathroom?
Yes, dear. All right. So this is paper two. Question number one is a choose question. Choose the correct answer. Number one says, when the rocks weather and are moved from one place to another. The word weather, guys, means, and you should be knowing by now, that weathering is when the rocks are exposed to extreme conditions of like very strong rain, very strong wind, and they start to break down into small pieces. This is what weathering of the rocks is. When the rocks weather and are moved from one place to another, dash are formed. What are formed? Let's take Julie. Is Julie there? I think she got out, right?
Miss, can I answer?
Yes, Ahmed, answer.
It is sediments. A.
Sediments, yes. Sediments are formed. Number two, an example of sedimentary rocks. Ali?
All of the above.
All of the above, the limestone and the sandstone. Number three, Salim, which one of these rocks is an igneous rock?
And igneous basalt.
Basalt, exactly. Thank you so much. Number four, Nancy, which of the following rocks is permeable?
Okay.
So we know that permeable means that it allows water to pass through them.
Chalk.
Chalk, very good. Okay, number five, Mira, which type of soil contains large particles and large air gaps?
Sand soil.
Sand soil, very good. Number six, basalt is a or an Adham.
Yes.
Yes, basalt is a or an igneous rock or sedimentary rock or metamorphic rock.
Can you say the question again?
Okay, basalt is a or an
Igneous rock.
igneous rock. Thank you. Number seven, the powder left behind when the rock is rubbed against a rough surface is, Ruqayya, are you there?
Yes.
Okay, Ruqayya. Which one of these is the powder left behind when the rock is rubbed against the rough surface? The hardness, the streak, or the luster?
Number 7.
Yes, dear.
Okay. Lost.
The powder left behind when the rock is rubbed against a rough surface.
Luster.
No, wrong.
Hardness.
No. It's streak. All right?
Okay.
We even saw a video about it. Do you remember?
Yes.
Yeah. Okay. Number 8. Matter is made up of tiny particles called, Lina. Lina? Lina, are you there? Hello? Is she there? Did she leave? Yeah, I think she left. All right. So let's just answer it. We only have 1 minute left. So matter is made up of tiny particles called atoms. Number 9, if two positive charges approach each other, they will repel. Number 10, the atom is neutral because the number of positive charges equal the number of negative charge. Yes. Number 11, the buildup of electrical charge on an object is static electricity.
Static electricity.
The flow of electrical charge through a circuit is current. Yes. Number 13, the only non-metal electrical conductor is graphite. Yes, graphite. Okay.
We tried
So-
it before and it keeps breaking. It kept, I mean,
What kept breaking?
the graphite.
Oh,
When we
yeah.
made
Yes, when we did it, yes, online. Yeah. Okay, guys. So time's up. It's 2:10. I'll be seeing you on tomorrow. We will be finishing paper 2, and we are going to continue with the 4th lesson afterwards. All right. So I'll be seeing you tomorrow, guys. Until then, I hope you're all fine. Bye. Bye-bye.
Bye.
Bye, dear.